Hello everyone, I am Purvajan and I am going to represent the topic of Navy bias classification. Here it is introduction of Navy bias classification. Navy bias is a powerful and versatile machine learning algorithm used for classification tasks. It leverages bias theorem to make predictions based on the probability of events occurring. In the presentation, we will dive into the fundamentals of Navy bias, explores its underlines assumptions, and demonstrated its practical application using real world example and code snips and R and Pythons. Introduction to Navy bias. What is Navy bias? Navy bias is a supervised learning algorithm used for classification tasks. It assumes that the presence of one features in a class is unrelated to the presence of any other features, hence the Navy part of the name. Second is when to use Navy bias. Navy bias is well suited from problems with multiple input features such as text classification, scheme detections, and sentiment analysis. It's also highly scalable and can handle large data set efficiently. Third topic is assumption of Navy bias. There are three topics over here. Independence is Navy bias assumes that the features used to classification are independent of each other, or linearity. Navy bias assumes a linear relationship between the input features and the target variables. The last one and the third, normality. Navy bias assumes that the input features follows a normal distribution. Bayes theorem. First PAIM IB, second is PBIA, third PB. Bayes theorem is the foundation of the Navy Bayes algorithm. It describes the probability of an event A occurring given the probability of another event B occurring. The theorem relates the conditional, the marginal probability of the two events. Superior probability. What is superior probability? Superior probability is the likelihood of an event occurring before any new evidence is taken into account. It presents the individual belief of knowledge about the event. Why it is important? Period probability is a crucial component of Bayes' theorem as it is used to update the probability of an event occurring based on a new evidence or importance. How to estimate priori probability? Prior probability can be estimated from historical data, expert knowledge, or assumption based on the problem domain. Likelihood. There are three steps over here. Probability of observing data. The likelihood is a probability of observing the current data given a particular hypothesis or model. Conditional probability. The likelihood in a conditional probability, which describes and the probability of the data given the model parameters. Maximizing likelihood. In Navy bias, the goal is to find the model parameters that maximize the likelihood of the observation data. Posterior probability. Prior probability, likelihood, posterior probability. This posterior probability is the updated probability of an event occurring after considering new evidence or information. It combines the prior probability and the likelihood to provide a more accurate estimate of the probability of the event. Next topic is Navy bias in R Python. R example. In R, we can use the Navy bias functions from the E1071 package. To implement the Navy bias classifier, the function takes is in the training data target variable and other parameters to build the model and make predictions. Python example. In Python, we can use the Gaussian NB functions class from the sklearn Navis bias module to implement.